Yeah. Hi guys, good morning. Happy Independence Day to all of you. So is my video
Happy
visible?
Independence Day, sir.
Yeah, happy Independence Day. Is my video visible, guys?
No, sir.
No,
No,
right?
sir.
Okay. Video is on, but no. Okay. Right, I'll just go and join again. 1 second, I'll just go back. Okay. Now is my video visible? Guys?
No, sir.
Still not visible, sir.
What is wrong? Okay, not required then. Like video is not required anyways. Okay. Fine, let me share my screen. Am I the host? Yeah, okay. Right, hope the screen is visible.
Yes, sir.
Yeah, right. So last class, what did we see? Right, okay, this is what we saw, right? So if you can remember, I think with, yeah, we started neutral agent reactions, right? I told you that acid plus base will react to form salt and water, right? And you have to remember that all neutral agent reactions are highly exothermic, in the sense that a lot of amount of heat will be evolved during the reaction, right? And I told you that depending on the strength of the acid and the strength of the base used, the amount of heat released will also be different, right? So in the sense that if I'm going to use a strong acid plus strong base, there'll be a huge amount of heat released. But if any one of them is weak, like say I use instead of a strong acid here, I use a weak acid and a strong base, the amount of heat generated would be a little less, right? Same way, instead of the strong base, I use a weak base. Again, the amount of heat generated would be less. And if both of them are weak, obviously in that case, it is going to be the least amount of heat which will be evolved during the reaction, right? Okay. So this we saw. And then we went on to salts. I told you that salts are of 4 types. There are acidic salts, basic salts, neutral salts, and amphoteric salts, right? So the name itself, you can understand what are these salts, right? So it is acidic in nature, one is basic in nature, one is neutral, and amphoteric means it is going to be both acidic as well as basic. It's like that. It can react with both acid as well as base, right? Okay. So fine. So now, how do you form all these salts? Say, for example, if I want to talk about acidic and basic salts, like all the salts are formed through neutralization reaction only, right? Acid plus base reaction, right? So depending on what acid you use and depending on what base you use, accordingly, you're going to get the salt, right? Say now, for example, if I have to get an acidic salt, right? So it is very much understood that I have to use a strong acid and a weak base because one of them should be dominating, the other should be less dominating. Only then I will be getting one of the higher result, right? So if it's a strong acid and a weak base, the end result would be something acidic because I use some acid. I use the acid to be strong, right? So now what you'll understand is that I'm going to get an acidic salt if I use a strong acid and a weak base, right? So example can be HCl is a strong acid, MgOH twice is a weak base, right? So I'm going to form MgCl2, which is going to be a acidic salt, and obviously a water molecule is going to get liberated, right? So now actually we didn't move on like the conventional method, right? So I told you, right? So depending on what salt is given to you, right? If they give you the salt, you must be in a position to say whether is the video still on? No, right? Second. I turned off my video already. It shows that the camera is still running. Okay, fine. Anyways. Yeah. So what I was telling is depending on the salt given to you. By looking at the salt, just by looking at the salt, you must be in a position to tell whether the salt is going to be an acidic salt or a basic salt, right? Like last class, we spent a lot of time on looking into this, right? So now what you have to do is any salt given to you for that matter, right? Any salt given to you for that matter, look into the cation and look into the anion, right? Look into the cation and look into the anion, right? Say, for example, I took aluminum nitrate, right? Say aluminum nitrate, I know what will be the cation or anion present, aluminum ion and nitrate ion, right? Aluminum ion is Al3 plus, nitrate ion is NO3 minus, right? Now, what you have to understand is the negative charge, that is the anion of the salt, always comes from the acid. Again, I repeat, you can see here, right? The anion is this part, right? The anion of any salt, right, will come from the acid part, right? And the cation of any salt will come from the basic part, and that is the base part, right? So now once you know what is the anion and cation, it's very simple to understand. To the cation, I told you it is going to come from the base, right? Add OH minus to this, right? So I'll be ending up with the base. In this case, it is going to be aluminum ion, and hydroxide, if you add it, is going to become aluminum hydroxide, right? Same way for the negative charge, for the anion, I told you it is going to come from the acid part. Just add a H plus, right? How many ever H plus you want, depending on the negative charge. If at all there's only one negative charge, add one H plus. If there are two negative charges, add two H plus, right? So like that you do, you are going to end up with the corresponding acid. So in this case, NO3 minus, if I add H plus to this, I'm going to get HNO3, right? Now once you get the base and once you get the acid, right, this should have been the acid, this would have been the acid, and this would have been the base for me to form aluminum nitrate, right? Now once you get what is the base and what is the acid, now you must know obviously whether it's a strong acid or a weak acid, or a very strong base or a weak base. If you know that, then you can easily tell which is going to be the salt, like whether it's going to be acidic or basic salt. So in this case, HNO3 is a strong acid, right, and aluminum hydroxide is a weak base. So obviously aluminum nitrate is going to be a acidic salt because I use a strong acid and a weak base, right? Okay, now we'll see one more example like this, right? Say I took NH4Cl, right? Now NH4Cl, what happened? Again, I have to look into what is the cation and anion present, right? Okay, so the anion here is Cl minus, cation here is NH4 plus, right? I told you the cation comes from the base, so add OH minus to this. So what will you end up with is NH4OH, ammonium hydroxide. Now the anion present here is Cl minus, that is an NH4Cl, right? So obviously I add H plus to this, you're going to get HCl. So obviously you understand that HCl is a strong acid, ammonium hydroxide is a weak base. Again, you understand that the NH4Cl is an acidic salt, right? Okay, moving on. Like say one more example, if I take NaCl, right? Now NaCl, you understand that again I have to look into the cation and anion. Cation is Na plus, anion is Cn minus, cyanide, right? Cation comes from base, add OH minus, it is NaOH, right? Now in the and for the anion add H plus, so H plus plus Cn minus will give you HCl, right? That is a cyanic acid. Now you know that NaOH is a strong base, right? And HCl is a weak acid, right? So obviously we understand that for a basic salt to be formed, I should have a weak acid and a strong base. Is it not? Like it's exactly opposite to that of acidic salts, right? So that's exactly what I have here. NaOH is a strong base, NaHCl is a weak acid. So obviously NaCN, sodium cyanide, is going to be a basic salt, right? So like this, we saw so many examples. For every example, the method is very, very, very same, right? You look into the cation, look into the anion. Cation comes from the base part. Anion comes from the acid part. So to the cation, add OH minus. To the anion, add H plus. You'll be ending up with the acid and the base. And then looking at the acid and the base, you can tell whether the salt is going to be acidic or a basic salt. Is it okay? Right? Does anybody has any kind of confusion in this? Everybody understood? Like now, if I give you a salt, you must be like, okay, let us check, right? Actually, we saw so many examples like this last class. That's written here, acidic salt should be strong acid plus weak base. For basic salt, should be weak acid plus strong base, right? And I hope this is just for you to, remember what are all the strong acids. Strong acids are these four: HCl, HNO3, H2SO4, H3PO4. And other than that, say HCN, H2CO3, CH3COOH, all common weak acids, right? Then if you go for strong base, right? Say only 3 are strong bases. Other than that, everything is base. I mean, everything is weak, right? NaOH, KOH, COH twice, all these are strong. All the other hydroxides, whatever be the other hydroxide, all of them are going to be weak. Okay, right? Fine. So this is where we stopped last class, right? And we are almost at the end of the chapter, right? Anybody has any questions to be asked from this particular part? You want to clarify?
So a weak acid and a weak base will form neutral salts.
Yeah. Okay. Coming. That's a good question. Right. Coming
Sir,
to that.
and one more question,
Yeah.
sir. Strong acid and strong base will so like same base, so like weak acid and weak base. So will it form neutral salt?
Coming to that point. Yes. Good point. Right. Okay. So now when I add a strong acid and a strong base, say for example, I add HCl and NaOH. Right. Now you understand HCl is a strong acid, NaOH is a strong base. Right. So I know I am going to end up with NaCl. I know the famous reaction, right? This is a very famous reaction. HCl plus NaOH is going to give me NaCl plus H2O. Right. Now this NaCl obviously is going to be a neutral salt. Now why? Because both the acid and the base are strong, right? So whenever you add a strong acid and a strong base, you'll always end up in a neutral salt, right? Now this is very easy to understand, right? Now, if I have a weak acid and a weak base, right? Now, yeah, you can tell that it is going to form a neutral salt, right? But the thing is, first of all, this reaction has to happen first. Right. So when I have a strong acid, a strong H plus donor, right? This from HCl, I'm going to get a lot of amount of H plus, and this is going to be a strong H plus acceptor or say OH minus donor, right? So both of them will react vigorously to form NaCl. The reaction is very, very fast, right? Say, but in this case, even though we expect a neutral salt, right? But most of the time, the reaction itself won't happen, or say, the reaction it won't happen, we can say in one way, or we can say that the reaction is so slow that it seems to be that the reaction is not even happening, right? Because we are using weak base, because only very few amount of H plus will come from this, very few amount of OH minus will come from this. They both reacting will take a lot of amount of time, right? So how do we put it is, yeah, obviously we expect a neutral salt, right? But this reaction going to completion, or this reaction even occurring, has very, very less possibility. That's what we need to understand, because the kinetics, or say we call the rate of the reaction, is very, very low. Okay, right? If at all you want any examples of these kind of salts, you can take anything. Like say I take HCN plus NH4OH, right? I know this is a strong weak acid, this is a weak base, so you are going to end up with NH4CN, that is, this is ammonium cyanide, right? Obviously that's H2. Okay, so this ammonium cyanide, you will see like this will be very traces of amounts of ammonium cyanide you will see in the solution. Like if you mix cyanic acid and if you mix NH4OH, right? If you make the reaction happen, you will see very, very, very little amount of NH4CN getting formed. And yeah, obviously it is neutral, no doubt about it, right? But the yield of the reaction, or say the efficiency of the reaction, is very poor. Okay, did I answer your question, Kanna? Is it fine now?
Yes, sir, I understood.
Right? Okay, cool. Any other questions anybody has from this? Okay, fine. So if there are no more questions, right? That's about the salts. Okay. Now there are some useful salts we use in our day-to-day lives, right? So this is about till now what we saw is we saw how to make salts, what are the different forms of salts, how do you make those different forms of salts like acidic and basic and neutral and amphoteric. We don't see. Of us three we definitely saw, right? But now what you're going to see is the applications, right? What kind of salts we use in our day-to-day life. Okay, right, fine. Now, among them, the first one is, can I call it as bleaching powder? Right, now we use bleaching powder, right, in our homes for cleaning so many things, or we use bleach as such, right? So we like, okay, this topics must have been gone over in your school, right? So I can expect an answer from you. Can someone tell me what is the formula for bleaching powder?
So it's CaOCl2.
CaOCl twice. This is how we write, right? It's not CaOCl2. No, this is wrong. You should write it as CaOCl whole twice. Okay. Now this is again a new kind of anion you are knowing here. This OCl minus again is a polyatomic anion, right? You can see two types of atoms are there. One is oxygen, the other one is chlorine, right? This is again polyatomic. I told you there's a difference between monoatomic, like say Cl minus. This is monoatomic because it is made up of only one type of atom, right? And the other one is like say polyatomic, which will be made up of more than one type of atom. Now in this case, it is oxygen and chlorine, right? Now this name of the ion is what is called as oxychloride ion, right? The name of the ion is what is called as oxychloride ion. Okay, now, so obviously this, right, can also be called as calcium oxychloride, right? But this oxychloride can be of different forms. Basically, you are saying OCl minus. I even have ClO2 minus, ClO3 minus, like this I have. So chlorine and oxygen combined together to form so many different kinds of polyatomic ions. We don't have to go into the details, don't worry about it, right? So what I'm telling is, in general, right, in general, if I have oxygen and chlorine together, right, they are called oxychlorides, right? All of them, or ClO minus, ClO2 minus, ClO3 minus, right? All of them together are what are called as oxychlorides because they have oxygen and chlorine, right? Now, this particular ion is what is called as hypochlorite, right? The exact name of this OCl minus is what is called as hypochloride ion. Okay, right? Fine. Now, so the name of the salt you can easily predict now, right? Calcium is there, right? And I told you the name of the ion is hypochlorite, right? Now you can easily tell the name of the salt, the name of the bleaching powder. The chemical formula is CaOCl twice, right? But the OCl minus is what is called as hypochlorite ion, right? So I can easily tell the chemical name of bleaching powder is nothing but calcium hypochlorite, right? This is what is the chemical name of bleaching powder. Okay, right. Now, yeah, how will you produce this, guys? Like, again, you should know, right? How do I produce bleaching powder? What reaction, you know, for this? How do I produce bleaching powder? How do I produce bleaching powder? What is the reaction I use? Anybody knows? In your book, is it there? Or you don't have that? Does anybody have your book with you? In your hand now? Or is it accessible to you?
Yes, sir.
Okay, look into it and tell me the answer quickly. Anybody, I mean, it's not like only one of you should do it. Everybody can do it so that everybody will remember. If you have your access to the book, I want you to go through the book and tell me what reaction will get you to CaOCl twice. That is calcium hypochlorite. Go for it. It's a reading assignment I'm giving you. I'll give you 2 minutes. Quickly open the textbooks, right? Quickly go to the chapter acid bases and salts and quickly go to bleaching powder and tell me what is the... yes, please go for it. What?
So you asked the equation, right?
Yeah, I need the equation. Correct.
So it is CaOH whole bracket 2 plus Cl2 gives CaOCl2 plus H2.
Okay. Right, plus H2. Absolutely. This is the reaction, right? So when you have calcium hydroxide, right? Calcium hydroxide reacts with chlorine to form calcium hypochlorite, that is CaOCl twice plus hydrogen gases are what. Okay, fine. If I tell you that there is an acid like this, HOCl, right? Now, this is again a salt, right? Calcium CaOCl twice, again a salt, right? So using this acid and some base, can you tell me how am I going to form this, right? That means I'm telling that this plus some base will give you CaOCl twice. Can you complete this reaction? HOCl I already told you, right? What should be the base here for me to get this? Any guesses here? It's very simple actually if you think properly. HOCl plus some base is going to give me the salt plus water. HOCl is the acid, obviously. You don't have to worry about what is this acid name and all. What should have been the base? Can you guess?
Calcium hydroxide.
Yes, exactly. So in this case also, if I use CaOH twice, right, I'm going to end up with the salts. Now it's very easy to understand. Look at this. I have HOCl plus CaOH twice, right? Now what happens? Now from this, H plus comes, from this, OH minus comes. So now they both will react to form H2O. That's very simple, right? Now look at what is remaining, right? Now from this, H plus is gone. So from this, what is remaining is OCl minus, right? And from this, OH minus is gone. From this, what is remaining is Ca2 plus, right? Now you can easily form the salt. Ca2 plus OCl minus, you switch up the charge, you will get up with CaOCl the whole twice. Okay, so either this way, that is calcium hydroxide, you pass chlorine gas, this is chlorine gas, to this, you will be ending up with your bleaching powder, that is calcium hypochlorite, or you can go for the normal neutralization reaction by using the acid as HOCl. Anybody knows what is the name of the acid, guys? HOCl? Anybody knows what is the name of this acid? HOCl. Actually, I have HOCl, HOCl2, HOCl3, all these things I have in HOCl3. Anyways, I don't have to worry about this too, but this is little, you can remember. Anyways, you will study about them when you go to your 11th. Yes, go for it.
Chloride, I think.
Hypochlorite is the ion. OCl minus ion is what is hypochlorite ion. What is this then? Now you can easily, I think, guess the acid. If it is hypochlorite ion, what should have been the acid name? Any guess? Just normal guess. Even if you don't get it, it's fine. Just a guess. Okay, so this acid name is what is called as hypochlorous acid. Okay, HOCl. Okay, this acid name is what is called as hypochlorous acid. Right. Anyways, but you don't have to remember this reaction. What I told you, this is just an extra information, right? Because you're talking about neutralization reaction and salts, I just told you this is also another way of doing it. Because we have the acid available, HOCl, hypochlorous acid, and the base obviously should have been COH twice, right? And this is your classical book, this thing, right? CaOH twice plus Cl2 will give me CaOCl2 plus H2. Okay, fine. Now, we say that bleaching powder cleans stuff, right? Bleaching powder bleaches, or I would say the bleaching action of bleaching powder, right? Now, you understand that that is also going to be a chemical reaction, okay? That is also going to be a chemical reaction. But what I have to understand is bleaching powder as such is not involving in bleaching action. Okay, so what we understand is this can be used as a disinfectant, right? Bleaching powder can be used as, so you can see in so many hospitals, there'll be let's say putting bleaching powder everywhere near the bathrooms, near wherever there can be a lot of prone to infections and stuff, right? So bleaching powder can be used as a disinfectant. Okay, now always remember, right? Always remember, whenever I have a disinfectant or whenever I have something to be a cleaning kind of stuff, right? Now that reaction is always going to be an oxidation reaction. You can remember this. Okay. Whenever you are killing something, whenever you are, antimicrobial actions, disinfectant, cleaning, bleaching, whichever comes with respect to this kind of stuff, right? Those are going to be chemical reactions. Okay, and you understand that all of them are going to be oxidation reaction. Okay, now you understand that oxidation means generally it absorbs heat, right? So obviously, whenever something absorbs heat, like say, why do we boil water and drink it? It's because you want to kill the all the microbes present in water before you drink it, right? So this reaction generally, again, I'm not telling you all the reactions, but generally, right, all these are oxidation reactions, and generally these reactions will absorb heat. So when they absorb heat, and obviously they're going to kill the microbes, and that is how the cleaning process happens. Okay, right. So this is one thing for you to remember. And next thing is, as I told you, a bleaching powder as such, that is CaOCl twice as such, will not involve in the bleaching action, right? Something will come out of the bleaching powder, right? Now that is responsible for the bleaching action. Okay, do you know what I'm speaking about? Anybody is trying to correlate what I'm trying to speak? Anybody wants to comment on this? I'm telling you, bleaching powder as such, that is CaOCl twice as such, is not involving in the bleaching action, right? It is something which will come from the bleaching powder that is only responsible for the bleaching action. Do you know what I'm talking about? Anybody wants to comment on this point? No, whatever comes to your mind from whatever I said, right? Whatever comes to your mind, you can share. What comes to your mind when I say this? Bleaching powder as such is not involved in the bleaching action. It is something else which is involving. What could be that something else? Can you think of that?
So something which decolorizes or reduce the color.
Reduce what?
So reduce like it.
Go on. It's okay.
Fades the color, sir. Like
Change the color of what?
some given substance.
Change the color of a given substance. Yes, possible. Okay, fine. Anybody else has any comments?
Sir, what was your question?
I'm telling that in bleaching powder, the formula is CaOCl twice, right? Now that I told you that there's something called as bleaching action, basically the oxidation reaction or whatever it is, something to kill the microbes, right? I'm telling you, CaOCl twice as such is not responsible for this. Something is going to come from this, some X is going to come out from this, and that only is responsible for the bleaching action. Can you comment on, or whatever comes to your mind, can you think about this, what I'm trying to say, or any comments on what I'm trying to say? What can be this X? Or any other point which you want to add to this, whatever I'm trying to tell you. Okay, I would say this X, if you want to understand, the clue is swimming pools. I don't know how many of you have been to swimming pools, or how many in your school there are swimming pools, right? But yeah, that's the clue I can give you. Swimming pools. Now, any comments? Still no comments?
Where is it? Hydrogen peroxide.
Hydrogen peroxide. Hydrogen peroxide, where are you in swimming pools? Hydrogen, yeah, actually what you're trying to say, I understand. Yeah. Hydrogen peroxide we use for cleaning the wounds. That is also a disinfectant, obviously, right? But they don't use it in swimming pools. No.
Sir, will it react with water and form hypochlorous acid?
Will it react with water to form? Okay, hypochlorous acid. Yeah. Yes. I mean, to little extent, but not like so much. But yeah, it might happen. Yes. Any guesses? Okay, what do they add in swimming pools to make it clean? Or another question, how many of you have been to swimming pools and when you come out of the swimming pool, your entire eyes would have been red? Is this thing happened to any of you? Or at least have you seen it happen to people? Like once they come out of the swimming pool, right? Their eyes would have been so red, or you will have so much of itching in your body sometimes. You know why it happens? Or basically, what did they use to clean the swimming pools? That is what is responsible for all of these. That is the eye irritation or skin irritation or the eye becoming very red, right? Something they use to clean the swimming pools. What do they use to clean the swimming pools? Any idea?
Chlorine, sir.
Exactly. Right. That is what I was looking for. So the answer is chlorine, right? This X is nothing but chlorine gas or chlorine in some form, not necessarily gas, right? So what you understand is, as I told you, the bleaching action of bleaching powder is not because of bleaching powder, right? From bleaching powder, this chlorine gas is going to get evolved. Okay. And that is the disinfectant. That is the one which is responsible for all the cleaning actions. And obviously, I don't know whether if you have gone to swimming pools regularly, you might know that they will tell, if at all once the person comes out and feels that there is his or her eyes became so red, they'll tell, hey, too much chlorine in the water. Right? Obviously, they understood that even the water will also smell different. Like say, if you go and swim in the water, right? Normally water doesn't have any smell. It is odorless. Right, but if it has so much chlorine, they have so much chlorine to clean the water, the smell itself will be different. It's like so much amount of, I would say, not bleaching powder smell, but I don't know whether you have smelled chlorine, right? Maybe if you get a chance, go to your lab and smell chlorine, right? Ask your lab in charge or your teacher to somehow create chlorine and ask you to smell it. Okay, that then you will understand what I'm talking about. Okay, so anyway, so what I'm trying to say is that the bleaching powder as such is not responsible for the bleaching action. It is the chlorine gas which comes from the CaCO2, that is CaOCl twice. That is responsible for the bleaching action. Okay, that is what is making the oxidation reaction happening. Oxidation of the microbes or oxidation of the dirt, right, is done by Cl2 and not exactly by CaOCl twice. Okay. Now, if you ask me, sir, how is it that CaOCl twice is able to form chlorine gas? It's very simple. The reaction goes like this. Sorry, CaOCl twice will, on reaction with air or whatever it is, just expose it to the atmosphere, you will see that they're going to have calcium oxide and chlorine gas getting evolved. Very, very simple. Now, this is what is the white powder you see. Right. So when you apply bleaching powder, right, if you have used bleaching powder in your toilets or somewhere, right, now when you just spread it, it is going to be a white powder. Right. Now, once you expose it to the atmosphere, right, once you expose to the atmosphere, what will you see is this white color thing, which is CaO, and you will get a strong smell right from the bleaching powder. Right. Everybody must have experienced it. Once you cross a place which is full of bleaching powder, right, you will get a strong smell. That smell is nothing but the smell of chlorine which is coming out of the bleaching powder, right? And this is the one which is responsible for the bleaching action. Okay, right? Anybody has any questions? Everybody understood what I'm trying to say here? Is everything clear?
Yes, sir.
Right? Okay. So what you have to understand is
The smell is due to chlorine, sir.
Absolutely. The smell is due to chlorine gas getting evolved. Okay, that is what is responsible. That I would say that is the disinfectant. That is the bleaching. That is only responsible for the bleaching action of the bleaching powder. Okay, right? Right. Good. So that is about bleaching powder. How do you produce it, and how is it that it is able to clean, or how is it able to be say used as a disinfectant? How is it used as a disinfectant? Because of this reaction, because of chlorine gas evolved. Okay. Now, next, that is one of our salt. I told you that we're talking about the applications of the salts, right? Okay. Now, the second salt which I have to talk to you about is this plaster of Paris, right? Or in famous, it's called POP, right? Yeah. Any guesses on the formula? Not guesses. You must know the formula. What is the formula, guys? For plaster of Paris? What is the formula?
So CaSO4 dot half H2O.
CaSO4 dot half H2O. Right. Okay. Forget about this. Now, when I write this half some H2O, what is this part called as? We spoke about this, right, in the first chapter. what is this part called as? Dot H2O, I write it. It is called as something, right? What is it called as?
So
Water
water
of crystallization.
Yes, it's called water of crystallization. Okay, now can you tell me how this exists? Like, how is it that I write dot H2O? Like, where does this water molecule, where is this water molecule present? I even told you that, right? How is it possible to have dot H2O? Or where this water is present? Any idea? I spoke about this last class. I mean, not last chapter. Right? Anybody remembers where this H2O is present or how this H2O is present? Any guesses? Or at least if you're not able to remember, any guesses?
Sir, it is shared between CaSO4.
It is what?
Sir, it is shared between CaSO4, sir. It is present in that.
Shared between CaSO4? No, not exactly. Anything else or anybody else wants to comment? Okay. See, please understand, whenever you are having crystals, right? Whenever you have the salt, not in the solution form, but in the solid state, right? When the crystal state. Okay, so please understand, there are going to be a lot of amount of arrangements. Like say, I can keep on arranging them like this, the crystals, right? So basically, I can tell that you understand, for example, any amount of salt, say this is Na plus ion, this is Cl minus ion. Again, next would be NaCl, next would be Cl minus, next would be Cl minus, next would be Na plus. So like this, you will have consecutive spheres of positive and negative charges. Okay, now when they arrange and form a proper structure, like you can understand, this can, like say, I can keep on making it into a 3D structure. A big crystal can be formed. Okay, now this is going to happen. This is how the crystal is forming, but that's not the issue. Now, when you look into it, say I put three, I put three spheres together, right? Now you see that in this, like say, if I can change the color, right? Say there will always be some gap here. Is it not? However, you try to pack it, or you understand the point, you try to remember it like this. Say, whichever room you're in now, right? You'll be in room, saying hall or room, whatever the place you're in, right? Now it is going to be a cube or a cuboid, whichever the place you're in, right? Cube or cuboid, how can I understand the difference? Right? Now, what you're trying to do is you are going to fill that particular room with tennis balls. Okay, you're going to use say hundreds and hundreds of tennis balls, and you're going to pack the entire room with tennis balls. Okay, now can you tell me, sir, with 100% surety that, sir, it is possible that there is no space left? Can I fix the entire volume with tennis balls? The answer is obviously no. Right? Because however you pack it, however say efficiently you pack it, there is always going to be some gaps. There's always going to be some gaps. Even though maybe you'll not realize it, but still there are gaps. Okay. And these gaps, when the crystals is formed, right? When the crystal is formed, is small enough that it can accommodate a water molecule. The water molecule is very small. Okay, this space, when I have the cation and anion sitting together making the crystal, right? There will always be some space, and this space is small enough, or say it is big enough for H2O molecule to go and sit into this space. Okay, that is how we get the water crystallization. Okay, that is so basically what you understand from this is that if I have one Ca2 plus ion and one SO4 2 minus ion, for every one Ca2 plus and every SO4 2 minus, I have half a molecule of H2O sitting in between. Right? Not sitting in between, like you can understand that what the voids or the empty spaces are going to be such that I'm going to have half water molecule present. Okay, so that is what it is called as water crystallization. So what you have to understand is there will be some space when a crystal is formed, so in that space, water molecule is present, and that water molecule is what is called as water of crystallization. Okay, very simple words, very simple. It's very simple to understand. Okay, right. So now, okay, you gave me the name, I mean the formula of the salt. So obviously I can talk about the name of the salt. Right? Anybody wants to comment? What is the name of the salt? This is the formula. What is the name? What is the name?
Calcium sulfate hemihydrate.
Correct. It's called calcium. So obviously CaSO4 I know is very simple, is calcium sulfate, right? And we have to include this also, right? Sorry. Right. So I'll write the full name. It's called calcium sulfate, that is CaSO4. For the half H2O part, it is only half H2O. So you write hemihydrate. That is half H2O is how we write it as hemihydrate. Okay, right. So we know I'm going to use it for we know where all the plaster of Paris is used for, right? For making any kind of statues, right? Or very famous example is when you fracture your hand or leg, right? So that mavakatte which they put for you, right? That is basically nothing but plaster of Paris, right? Lot of other things. Even in some case, even cement. Sometimes little amount of POP is kept, right? And sometimes POP ceilings are there, like you must have seen in some houses, right? The ceiling paint which they use will be of plaster of Paris, right? So like that, in so many situations, so many applications are there for plaster of Paris. It's very easy to mold it, right? It's like clay, right? How you have seen clay, like in Tanjavur, if you go, you'll see a lot of amount of clay statues and clay articles like that. So like the plaster of Paris also little like clay, but say it is like very similar to clay, but different color, like white color, obviously it is. Okay, all right. Now, how do you produce plaster of Paris? Yes, in that question, and anybody knows the reaction? How do you produce plaster of Paris, guys? Basically, what is the raw material we use for producing plaster of Paris? The name. From what we get plaster of Paris?
The gypsum.
Okay, gypsum. What is the formula for gypsum? It is GYPS.
CaSO4.2H2O.
CaSO4.2H2O.
Yes, CaSO4.2H2O, right? So gypsum is the common name. If I have to give a chemical name to this, how will you give it? Next, like plaster of Paris is the common name, but the chemical name is calcium sulfate hemihydrate. So like that, for gypsum, it is CaSO4.2H2O. What is the chemical name of this?
So calcium sulfate dihydrate.
Exactly, very simple. Now this was hemihydrate because I had only half H2O. In this case, I have 2 H2O, so it is going to be dihydrate, right? So it is going to be calcium sulfate dihydrate. Very simple. Okay, fine. So this is the starting material. What I have to do to this to be ending up with POP, that is your CaSO4.half H2O. What should I do here? To convert gypsum to plaster of Paris. What should I do? What should I do? Simple, right? By looking at it, what is the difference between these two?
Sir, we need
That's it. Very simple. Very, very simple. Here you have 2 water molecules per CaSO4. Here you have only half H2O molecule per CaSO4. Obviously, you're going to heat it, right? So that 1.5 H2O gets evaporated, right? 1.5 H2O gets evaporated. Does anybody know what is the temperature which I have to use here? What temperature I have to heat gypsum? Come on, go into your book and tell me the answer.
So 373 Kelvin.
373 Kelvin, or in degrees Celsius, how will I write? This is in Kelvin. in degrees Celsius? In
So will
degrees
it be
Celsius?
100 degrees Celsius?
Yeah. Okay. I think I forgot to tell you about this conversion in the previous class. Okay. Now, please understand, people. Right now, 0 Kelvin. Sorry. 0 degrees Celsius. Right, is 273 Kelvin. Remember this. Okay, 0 degrees Celsius is 273 Kelvin. Okay, so now you want to convert degree Celsius degree Celsius to Kelvin. Like these are two different scales. How you have a centimeter and meter, liters and meter cube for volume only, right? So like that, Celsius, degree Celsius and Kelvin are the scales, different scales for temperature. Okay, now before we move on to see how do you convert this, out of these two, like actually I have three things, right? Degree Celsius, degree Fahrenheit, and Kelvin. You must have heard all of them, right? Now among them, which is the SI unit of temperature? Well, okay, first of all, what is SI's full form? We write SI unit so many times, right? What is this SI full form? Okay, coming back to that, what is the SI unit of length? Length, what do you measure it? You measure it in inch. Okay, you measure it in inch. You can measure it in feet. You can measure it in meters, right? So out of these three, only one of them is SI unit. Okay, first question. Have you ever heard this term SI unit before? Have you?
Yes, sir.
Okay, you've heard. Then you can tell me what do you mean by this SI? Okay, I think we don't know, no problem. So it is
The
called
standard international unit.
correct. Standard international unit. Right. So the thing is, for a particular quantity, right? Say length, volume, temperature, pressure. These are all physical quantities. Right. Now there are different units available for them. Say for example, as I told you, length. If you check, right, it can be in terms of inch, right? It can be in terms of feet, right? It can be in terms of meter or kilometer or centimeter or millimeter, whatever it is, right? Now, obviously, throughout the world, there should be some kind of, unity, right? So that there is no much confusion when I go from one country to other country, right? For example, when you now go in India, you go to a temple and you ask for, Aman, 3 muram poo kudunga. Right, they will understand. But same thing you go and tell in America, you go to a flower shop and tell, give me 3 whatever bottoms of flower. He will laugh at you. He will not even understand what is that, right? So just to avoid all these confusions, we internationally we use one unit common for all the physical quantities. Okay, that unit, particular unit for a particular quantity is what is called a standard international unit. Just to avoid confusion, universally, in the sense that throughout the world. Okay, for length, it is meter. Okay, the SI unit is meter, right? For volume, anybody knows what is the SI unit? Like volume can be measured in meter cube, liters, I don't know what else. So many things are there, right? So like that, does anybody knows what is the SI unit of volume? Is it liters or meter cube?
Meters.
Meter cube, yes, right? The SI unit of volume is meter cube. Liter is a commercial unit because that is what we have been using for a long amount of time, right? So like that, every physical quantity, right, has as commercial units, like say inch, feet and all. Obviously we use commercially, like say for all, I want to measure the area of the building, something like that, right? We go for inch and feet, right? But meters internationally everywhere they know like that. Okay, anyways, so again, you look for like weight. If you remember weight, right? They'll say pounds, what is it, kg, whatnot. So many things are there. Again, kg is what is the SI unit. right? So like that, you have 3 units for temperature, that is Celsius degrees, Celsius Fahrenheit, and Kelvin. Remember, Kelvin is the SI unit. Okay, Kelvin is the standard international unit. Okay, so a lot of times you have to convert degree Celsius to Kelvin, or say Kelvin to degree Celsius. You have to convert that because maybe sometimes it is required. Okay, now how do you convert it? I'll tell you. Right, say degree Celsius value is given to you and you have to convert it to Kelvin. Right, now what you do is, if you want to get the Kelvin value, it is equal to 273 plus the degree Celsius value. For example, if I tell you that it is 100 degrees Celsius, right? I want to convert this into Kelvin. Now what you do is you add 273 to this. 273 plus 100 degrees Celsius will give you 373 Kelvin. Nothing, right? Whatever is the degree Celsius value, add 100 to that. That I'm going to give you. I'm going to get the, sorry. I'm so sorry. Whatever is the degree Celsius value, add 273 to that. Okay, whatever the degree Celsius value, add 273 to that. Whatever the value you get, you are going to get it in Kelvin. Okay, and it's going to be ulta for your opposite process. That is, if you want to convert Kelvin value to degree Celsius value, right? Now remember, for degree Celsius value is equal to the Kelvin value minus 273. Okay, just exactly opposite. Okay, so I can write Kelvin value is equal to degree Celsius value plus 273, or say degree Celsius value is equal to Kelvin value minus 273. Doesn't make a much of a difference. It's same basically. Okay, so either you remember this or this, you can easily get the other value. Whatever is given to you, you can easily convert into the other. Okay, right. So why did we start all this is because we have to convert gypsum to plaster of Paris. What you have to do is just heat it, and to what temperature exactly? 100 degrees Celsius or say 373 Kelvin. You will lose 1.5 water molecules and you'll be ending up with your CaSO4. Okay, now remember this CaSO4 is a very soft substance. I told you it's like very moldable substance, and this gypsum is very hard. Okay, right. So now if you have the experience of fracturing your hand or fracturing your leg, how many of you have? Can I put in the chat box? How many of you have the experience of fracture with you? Put it in the chat box. There are already 4 in the chat box. Chlorine. Okay, fine. Yeah, put in the chat box, guys. How many of you have experienced fracture? I'm looking into the chat box. Put yes if you have already experienced. Nobody. Literally nobody. Nobody has experienced fracture. At least guys should be there. At least one should be there. Okay. So you are okay. Arman says no. Okay. Interesting. Right. When I was before I finished my 12th, right? Before I finished my school, I broke my hands 2 times. Right. In the sense that one time left hand, other time right hand. And both was like little amount of naughty stuff, playing and like kind of stuff. So maybe I can tell you one of the story. Right. So when I broke my right hand, it's right shoulders. Okay, right shoulder bone like completely broke. It's like not even a fracture, it just broke. So what I was doing is I was playing kabaddi when I was I don't remember, I was in some 5th or 6th. I don't exactly remember. So when I was playing kabaddi, so I was trying to catch a guy who's like say 3-4 times the size of me. Like I don't know whether you looked at me, I'm a little lean, like at least I look lean, right? So there was this guy who's like 3-4 times like bigger than me. So I was trying to stop him and all. I stopped him, like that's not the thing. But when I stopped him, he fell on me, right? And he exactly fell on my right shoulders, right? So the bone just broke. Literally it broke. That's what happened. Not even a fracture, not even a hairline crack, nothing. It just broke. So they have to give me anesthesia and then only do the operation, and then they put this plaster of Paris thing around me, right? So that basically I want to tell you the feel of this plaster of Paris. But very surprisingly, very surprisingly, nobody has experienced, and thank God that nobody should experience it. All of you should be safe. All of you should be good. But yeah, this is a good experience. Like when you go for, especially for guys, right? When you go out to play, these are not a normal things which will happen. Like when you play, when you go for cycling, when you ride, this is not a very normal things will happen. But you have to be very careful, obviously. You have to take care that you're very safe and all that, very, very important. But anyways, so yes, so what I'm trying to tell you is if you've at least seen people when they are putting this POP's band, right? Now, what will you see is when they put the band, it is very, very soft. Okay, when they put the band, because then only you can easily mold it according to the hand's structure, right? Or then only you can easily press it, mold it, all that you can do, right? But after a point of time, like you must have at least seen your friends or someone when they put that mavu cut and come to your class, it will not be soft. It will be very hard, right? So what do you understand from that? When you put the plaster of Paris fresh, right? It is actually plaster of Paris. That is why it is soft. You can mold it, right? But once you give it some time and once it becomes hard, it converts back to gypsum. That is why you see that it is hard. Okay, because you are exposing the atmosphere, you're cooling it, isn't it? Only at 100 degrees Celsius, right? See, only at the boiling temperature of water, only then the plaster of Paris exists. But say at the room temperature, 25 degrees Celsius, that is room temperature. Obviously, what will happen? The opposite reaction will happen. That is CaSO4 dot half H2O will convert back to CaSO4 dot 2H2. That is gypsum. And that is why initially when they put that mavu it is very soft. But when after some half an hour, 1 hour, you see it would have become very, very hard. Right? Only then the bone will set. If you, I don't know if you have experienced anything with fracture, anybody who had experience of fracture, and they'll tell you this, that mavu has to be very proper so that the bone sets properly, right? So it has to be first molded properly according to the length or the size of your hand, and then it becomes hard again and it becomes very tight, and then the bone sets. That's how it happens. Okay, right? What is the time? Yeah, I think we'll stop with this for today, right? Today we saw two salts. One is I think your bleaching powder, and the next one was plaster of Paris. Okay, anybody has any questions you want to ask me, guys? Any questions anybody has? Is everything okay? Right, so if that's the case,
Sir, in
I'll stop.
a reaction where plaster of Paris is formed, sir, what happens to the 1/2 H2O, sir?
Oh, okay. That H2O comes from the atmosphere, right? So what you okay? I understand what you're trying to ask, right? I'll share the screen again. So you are telling that, say, if I have the CaSO4 dot 2H2O, if I heat it to 100 degrees Celsius, I form CaSO4 dot half H2O. What happens to the other half? Other 1.5 is what you're asking. The other 1.5 will evaporate as water vapor. It will go into the atmosphere, right? And when you convert this back to the gypsum, right, you actually add little amount of water to cool it down so that it becomes again CaSO4 dot half 2H2. Okay, was this your question, Kanna? Is it fine?
Yes, sir, I got it.
Yeah. Okay. Anybody has any other questions? Right? Okay. Cool then. Thank you so much, people. It was a good class. We'll meet. I think in this week only we'll meet again because we missed last week's class, so I'll be compensating it. Right? So they will inform you in some weekday. Right? I will have an extra class for you, 1 hour class, and you will get the timings and which day it is very soon. You will get from Epsilon Academy. Okay, fine. Thank you so much, people. We'll meet again next week or in this week only. Very soon we'll meet. Thank you so much. I'm ending the class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, everybody.